Hello, and welcome to another episode of Amiga Retro Adventures. This video is a follow-up to one of my last ones regarding an RGB repair. If I believe correctly, it was on the red register. Basically, it was lacking the red component of the RGB signal. So, if you recall, once I got that resolved, the image was horribly washed out, very bright, oversaturated. It pretty much couldn't see, any detail because it was that washed out. Now this is the same computer using the OSSC, so it's the same hardware as before that you witnessed the washed out video. And as you can see, it looks rather nice. So what have I done? Well, I don't like to give up. So I did some troubleshooting. So I will show you with the camera, of course, what I did to troubleshoot the problem. So let me zoom it down here to the piece of paper, move the camera gently. Okay, let's see how well this works. So this is a quick troubleshooting that I did on the video DAC. As you can see, there's a point here called V reference. It's a voltage reference. Now, I measured that on the board, and lo and behold, I was getting 5 volts, or 5.1 volts. Pretty much what the power supply from the Amiga 1200 was putting out. Now, you can see here, there's an LM385, which is basically, it's kind of weird. It's a 8-pin package, but it's basically just a Zener diode. Now, I'll move the camera over here, and a lot of these boards do not, I'll zoom in a bit, 1 second, if you can see it, do not have them included. The IC, basically the Zener diode that regulates whatever voltage it gets in this case 5 volts, to 1.2 reference voltage for the CDAC, it's right there, but it's missing. Well, it's not a defect, it's just not included in this item. Sorry, on this motherboard. And you'll see if you ever Google a lot of images from the Amiga, motherboards, various revisions, not just this one, revision 2B, several. I've seen them on other ones like 1D4 and so on, that sometimes they're just not included. So in that case, it just basically relies on the chip itself producing the 1.2 volts that it requires, because it can do it internally. It's a bit confusing reading the PDF document on the actual video DAC, because it can get an external reference or it can use an internal reference of 1.2 volts. So I will zoom back. Oh, very zoomed here. Zoom out a bit. Out. I always do it in the wrong direction. There we go. So basically, this doesn't exist. Let me move that over a bit more and down. So this isn't even in the circuit. So basically all you have is the 1K resistor, which is going to basically act as current limiting, and it's go directly into VREF, which means it's got to be referenced to ground somewhere in there. There should be some kind of voltage divider to drop that down to 1.2 volts. So I think there might be something wrong with the chip. I don't know for sure. I am not sure. But it works now. What I did is I actually added a resistor to ground. I believe about 330 ohms. And it brought the voltage down. So basically I just tied it from here. So there's VREF, there's the 1K resistor. And I tied it to here underneath the motherboard to ground. And it gave me about 1.29. The document for this chip, it ideally likes between 1.14 and 1.26. So I'm pretty close. I could put a different resistor in there. I figured around a 270 might do it, but I don't have any lying around. But it made a big difference, as you can see right now. That is a lot better than it was previously. And you definitely can say that it is a massive improvement. So all I can say is there's something that wasn't quite right with that chip, and I do have spares, but I don't really want to have to unsolder it and replace it. because, you know, I'm not 100% sure. I'm close to it because there really is nothing else, like in that circuit I showed you, that could be limiting the voltage. So maybe something inside that chip, you know, is no longer, you know, producing the correct voltage, like the 1.2 volts reference voltage that it needs. So that's pretty much it for this video. So just to show you that I am getting the correct voltage, one moment, I will go back down to the circuit board and grab my multimeter. Not sure if I can put that in frame or not. Of course you can't see it because we're too zoomed in. I will go back to the multimeter. It's right there. So what I'm going to do, I shall, 1 second here. It's pin 18 that is the voltage reference that it wants, the 1.2 volts. So if I hold this up here, that would be this pin right there. So if I orientate this to the way the sheet is, to the chip on the board, pin 18 is right there. So I will probe that. We should get about 1.29 volts. Remember, before I was getting 5, and that's probably why the image was so bright. The wire in the way. Here we go. I'm going to try to zoom in on the meter a bit. And I have to turn it on because that helps. And it defaults to DC. So here we go. And as long as I don't mess up the probing, we should get, well, one moment. This is actually it's 1.21 volts. So that's actually not too bad. The 1.29 I got was from a different power supply. That's why you use a Zener diode. It will always regulate it. It's basically Zener diodes are low amperage voltage regulators. They can't have large current draws. But with this power supply, I'm bang on within that range. Remember, 1.14 to 1.26. The other power supply must have put out a bit more voltage. I was getting around 1.2829, but I'm still a lot better than 5 volts. So that seemed to have fixed the issue. Like I said, there's probably a problem with the video DAC, but it's not, you know, the end of the world. This little hack, I guess, this fix, works fine. Of course, I have a spare just in case the chip itself decides to finally pack it in one day. I do have a replacement. But like I said, removing surface mount chips, unpleasant. So instead of staring at my speaker, I will show you, I'll zoom out again, once again, wrong direction, where I did the modification. So let me just turn the power off. Okay, it's off, and I'm going to just unplug a few components here so I can turn the board over without destroying anything. Because, you know, once you fix something, you want to stay, you know, you want it to stay fixed. So let me unplug this connector, joysticks, audio, RGB, and power. There we go. So what I did, and I mentioned before, back to this picture here. Remember, there is no Zener diode here. Like some revision motherboards, they just do not have it. So the chip is going to use an internal reference. Like I said, there must be something wrong with it because there's nothing in this circuit that ties it to ground. And if one of these capacitors was malfunctioning, maybe it could be bumping up that voltage. I'm not sure. Everything seemed to be fine. But like I said, this is a bit sketchy, but the resistor that I put, so I created a voltage divider network because you have 1K to plus 5 volts, and I put 270, so there's going to be more like ohms, because 270 is ideally, like if you, okay, let's say if you put 1K here, you get half, you get 2.5 volts, because you're, you know, 1K to positive, 1K to ground, the reference point in the middle, it'll see half the supply voltage. So I wanted to bring it lower than that. I had to lower the resistance to ground, so I put a 300 and I think 330 ohm. I wanted to put a 270. I did not have it, but like I said, I think the 330 is fine. I don't have to touch it because on this power supply, it's right in the ballpark. It's about 1.21 volts for the voltage reference. So what I did is I put that resistor to ground, and where I did that, and I didn't have any surface mount. I know some people say, "Oh my God, how dare you mix such things with through-hole components?" But it wasn't that bad. what I did, if I can find it, is put the board here and move the camera a bit, and I will attempt to zoom in, and there's the resistor. So that's the 330 ohm resistor that I tied to ground, which is this point right here, to the bottom end of the 1K resistor. So the one side of the 1K resistor is tied to positive, V plus, 5 volts, and then it ties to that midpoint. I don't know how zoomed in this will be. It's really zoomed in. Yes, you can barely see it. 1 second here. Yeah, that's better. I'll slide down like that. That works just fine. So right, you can see it. Sorry about that. Yeah. So I tied the that resistor is basically where this Zener diode would have been, which they never installed anyways. I remember that was that weird 8-pin packet Zener diode, even though there's technically 2 connections. But yeah, that's it. So that created a voltage divider, because remember, 1K up here, and if you remember I said it before, if you have another 1K, that will just split it in half. But if you want to lower the voltage, then you got to make this value smaller, because it will pass more to ground. And then I put it to 330. And it brought it within spec. And that's it. So hopefully that wasn't a bit too confusing, and I explained it pretty well, but that's how this motherboard has been brought back to useful life once again. So I can say another successful story from the Amiga 1200 side of things. Sorry about that cut there. I accidentally once again hit the record button while I was trying to move the camera. But like I said, that ends this story and this video, and that should be 1 second. This is it. That's it. I can't zoom out anymore. Perfect. But that's it. So that should be it for the videos until probably near the end of this month, which is July, because today's July 1st. But other than that, I hope you learned something and you found this useful. Like I said, I just wanted to make give a follow-up of that washed out video from the last one that I made about the RGB issue that this motherboard had. So thanks for watching, and see you soon. Bye.